Okay. Hey, wonderful OAUTH people. Let's get started. This is the second OAUTH session this week. We have another one tomorrow. You've been to the first one already, so you know the drill. We have the Node well pages, which you should be familiar also already from the other working groups you've attended during this week. I have a meeting minute taker, George, but hopefully, okay. But if someone else can also take some notes, Peter, thank you. Yaroslav, excellent. Brian, you're already in the queue. Oh, okay. A mistake, okay. Okay. No problem. Yes, go and quickly scan the QR code before it disappears. And in general, like everyone, please scan the QR code so we know who is in the room, not just because you may want to later go to the microphone to ask some questions. My co-chair, Rifat, is in the first session, he is online. Rifat, are you there?
Yep, I'm here.
Awesome. Thank you, Rifat. Okay, we're ready to go. Yeah, I talked about the Node well and the fact that we showed it already, talked about it. Then you are already familiar with the Meet Echo and the way to join the reg sign up, scan the QR code, etc. Two things we wanted to mention at the first session already, but failed to do so because of time issues. So there are two sort of kind of announcements, so to speak. Rifat added those to the slides. The first one is this federated credential management API. So work that has been going on for about 2 years. We've had some interactions with the relevant parties there, starting maybe 2 years ago already, which in the context of getting rid of third-party cookies and changing potentially the redirect flows and making all sorts of other changes in the browser, which have an impact on the way how our protocols work. So I think this is an interesting topic that we need to discuss. There will be various information and discussion events this year. And Rifat and I are planning to hold a working group intro meeting, as it says here on the slide, in the following weeks, maybe sometime April or so. And the group working on this technology agreed to give us an sort of kind of an update, and then we will have a discussion and figure out on like what does that specifically mean for the work we've been doing in the past and also going forward. And I think it also relates nicely to some of the work on native applications we've been talking about. Aaron has been presenting this work at the last IETF meeting and so on. So there's stay tuned, so to speak. The next item is, and we made that announcement already at the last IETF meeting in Prague. There will be another one of those OAuth security workshops that we have held in the past. This one is coming up really soon, April 10th to 12th in Italy. And yeah, you can register, go there, and enjoy the show. Good. Now getting to the, sorry about that. Getting to the agenda. So for today, we have several items: SD, JSON Web Token VC, the status list update, the attestation-based client authentication, a nonce endpoint, status attestation, and a short presentation about the new document that was proposed where there's some early input requested. So that's really short. The last, or the former two nonce endpoint and status attestation is a new document that was posted by Ori to the list and got some discussion input. And the first 3 in the agenda are working group items that we want to start with first. Okay. And I will stop talking and switch to the real content. Okay. And I think it was Daniel. Daniel,
Yes.
are you going
Hello.
present?
Yes.
Okay, you just tell me when I should switch the slide. Is that good for you?
That works for me. Yeah. Let me see if I can switch on my camera. I can. Hello, everybody. Yeah, I'm going to talk about SD.VC and that it's work together with Oliver and Brian. Hello, Brian. I don't see you, but you're also in the room, I gather. Okay, next slide, please. The agenda will be the usual, what happened since last IETF and what are our next steps. Specifically, today I'm going to talk about something that's called SD.VCDM and the problem that is solved by that and how we want to solve that and what that means for SD.VC. Next slide, please. So since the last IETF meeting in Prague, we published 2 new versions of the spec 02 and 03. Next slide, please. And as you can see on the picture, it's 02 and 03 were really close together. That's because we just made a minor change in 03. Yes, next slide. So what did we do? Many small changes, really. So we updated the rules that we have on how to obtain the public verification key and what steps you have to follow for the validation. The usual editorial changes. We had something that was called JORD issuer metadata. We renamed that to be more precise and more closer to the content of the spec. So now it's called JORD VC issuer metadata. We made the IAT claim optional, and it's now also allowed to be selectively disclosable. We fixed an inconsistency in the .well-known path construction. You can probably guess what that inconsistency was, and added a registration request for the IANA, some formatting and stuff, and clarifications in the text. And we also updated the examples that we have in the spec. Specifically, we also added an example for a PID credential, so person identification data from the EU digital wallet context. And then in 03, we fixed that example because one disclosure wasn't working. And we figured out why, and then we fixed that in 03. Okay, next slide, please. So that's what's new. Now let's look at what's next. Next slide, please. And the stuff that I'm going to talk about is comes directly from what we need and what we identified as problems in the EU digital identity wallet context. Next slide, please. And for the EU digital identity wallet, there's a document by an expert group of the European Commission that's called the Architecture and Reference Framework. I suppose that many of you are familiar with that. And there are some hidden gems in that document. For example, it says that you have to use W3C verifiable credential model, VCDM 1.1, and you have to use selective disclosure JORD, so SD JORD. But so how exactly those are used together is not defined, and that is a bit of a gap there. And that led to some interesting discussions among the member states, how this combination can be achieved, how it should be achieved, what exactly, which things you make selectively disclosable, which you don't make selectively disclosable, whether everybody needs JSON LD and stuff like that. So we have those two technical specifications, and they cover slightly different areas, and they are not like, they are compatible in various ways, but it's not clear what way is the best way and how a combination of the two can be achieved in a useful way. So that was a problem that we had, and we talked to many other member states about this, and it was clear that there are different opinions on this, and we have to find an alignment. Next slide, please. To figure out what is the best of both worlds between those two. So, for example, VCDM, there's not a single defined selective disclosure mechanism, so you can use it with SDJOT, but how exactly would you do that? You can use it with other mechanisms as well, but those are out of scope of the ARF. Then there's the old JSON versus JSON LD topic that I suppose many of you are familiar with. And from the use cases, we got the feedback that those use cases, or some of the use cases already using W3C VCDM in Europe, they have, so they obviously use JSON LD in the sense that it appears in the credential, but they also told us that they don't really process it. So for them, they have their use cases. They need to find a credential format that works with JSON LD so that they can continue for those existing use cases to use it, but also that they would be quite happy with non-JSON LD credentials for new use cases. And especially when you want to have very simple credentials, I think it's a good thing to not have to use having to use JSON LD. For example, for the PID credentials, I don't see a reason to use JSON LD for those. And finally, in Europe, there's the ETSI ADAS family of standards, especially JADAS, so JSON JWS-based electronic signatures that are already defined in ETSI. And many trust service providers have built services and systems around those specifications. So if the credentials can become ADAS compatible, that would definitely be a plus. But it's not clear how you would do that with the VCDM. Now, if you look at SD.VC, the ADAS problem still exists because the it's in the current form or in the form it was before we started this work. It was also not immediately ADAS compatible, and it lacked some other features that you can find in W3C VCDM, specifically the option to express schemas and to express or define vocabularies for your credentials. So Oliver Taboo, Alan Horvath, and I, we sat together and tried to work out what could be the best of both worlds here. So the idea is to define something that combines the strength of those approaches, that specifically is also compatible to existing use cases, meaning you can use JSON LD if you want to, and you can use W3C VCDM if you want to. But that also produces or gives us an option for very simple credentials, gives us exactly what we need in terms of schemas and vocabularies, and so on. So that's what we did. So we came up, next slide, please, with a proposal that we called SD.VCDM.
Daniel,
whether that's a good name or not, we can
6 minutes left
later.
and 12 slides slides. Just saying.
Okay. Yeah, I'll try to speed up. So the SD.vCDM proposal is a format that essentially does what I just said. So JSON-based credentials in the EU context and PIDs and QEAAs based on verifiable credentials, taking into account existing data models, formats, and securing mechanisms. Next slide, please. And the idea is that this is based on SD.vC. So we take the existing standard and define it, or we extend it in very specific ways to cover those areas that are not covered yet. In the SD.vC world, this could be called type metadata. It was a gap in the spec anyway. There was no definition of a type in SD.vC. So we said that a credential can have a type, but what is a type? So that definition was missing. And this is something we'll add that will give us the opportunity to introduce mechanisms to have type hierarchies, to have schema information, to have rendering information and other things in the type metadata. We try to keep it as simple as possible and as few claims predefined as possible. So you can use your data structures from your existing use cases and just put them into credentials of this type. So this is also, if you want to, compatible to W3C vCDM version 1.1 or 2. So you can layer that on top of this. You can use JSON-LD if you want to, but you don't have to. Next slide, please. The idea is that in the credential itself, there's a core data model, which essentially just says you have to have a type in your credential. You can have other information there as well. Obviously, for example, status list information or an issue or whatever. But the only thing that is really required is a type. And that type can be resolved to type metadata, which can extend other type metadata. And there's various information in that type metadata. Yes, next slide, please. And I think we can skip this. I essentially said that already. So this is what a PID credential, so person identification data credential in the EU context, could look like. Very minimal data set here, also very simplified example. But you can see that VCT is, in this case, it's a URN, which could be registered somewhere. There could be a defined resolving mechanism to figure out what the metadata is from a registry or wherever. But VCT could also be a URL so that you can just go there and retrieve the type metadata. Then there's application-specific claims. We don't define those. These are just, in the example, like given name, family name, birth date, and a CNF claim to enable key binding of the credential. Next slide, and then the next slide, please. And here's a more complex example, taking an existing data structure from the so-called portable document A1. What that is not important, but the point here is that this is also a valid credential for SD.vCDM, in this case with more application-specific claims, and that is not a problem for that format. Next slide, please. Next one. And the next one, please. So how do we get there? What do we need to do, or what do we plan to do? Next slide, please. The idea is that so with SD.vC, we already have a good basis. It's a very simple format. The thing that we need to extend, and that we always wanted to extend actually, is the type metadata. We already have a proposal for that, what that should look like, or what that could look like. It's not quite complete in terms of features yet, but we're working on that. And we already have the first pull request open for SD.vC to implement that type metadata. And we need to define some extension points, essentially just saying if you want to express a status information mechanism somehow, this is the place to do it. We also did a minor update to SDDraw to align with JDIS so that SDDraw becomes JDIS compatible. And in etc JDIS itself, there will be a very small update required to cover or to enable SDDraw credentials that are signed by JDIS in a compact format. Okay, and that's it. Thank you. Next slide, please, if you want. Right on time, I guess.
Thanks, Daniel. When you say define type metadata, proposal exists, where's that proposal?
I can share the URL in the chat here.
Cool.
Yeah.
Mike.
And the rest is some notes in my notebook that we discussed internally, but we'll create proper pull requests on SDDraw VC for this.
Dr. Fett.
Dr. Jones.
I'm curious about the define extension points language. The reason I say that is generally in our data structures, we just say that you must ignore stuff you don't understand. And so you can add stuff to JSON or CBOR and you're good. I mean, you're hinting about status and policies and whatnot, but what are you getting at there?
So the thinking was essentially that right now in the status list proposal, for example, there's a definition of a claim called status for your job where you would use the status list. And the discussion that we want to have is whether that definition of that claim should not move to the credential format, so in this case, SD.VC, and potentially could also serve for other status mechanisms, like a different type of status list, for example, so that you can use both of them or provide both of them. I don't know what the exact semantics would be, but also because there might be use cases and also sectors that already have such mechanisms that want to express it in those credentials. That's the idea here.
Okay, that makes sense. Thank you.
Thanks.
Daniel, you specifically focused on the requirements and needs from the European Union with the work that is going on there. How do we ensure that that use cases that are sort of come up elsewhere in other sort of parts of the world are also covered, so we don't tailor it specifically to the EU sort of circumstances?
So we try not to do that, but of course that's a good point, and I guess that's also a question to the group if anybody has concerns about this or other use cases in mind. So we developed this proposal several weeks ago. We have this website that I'll share in a moment, or Oliver can probably share it while I'm speaking, where we have essentially a bit of a longer version of the presentation that I gave here. And so far, we've had mostly positive feedback from people who said that sounds interesting to them to have this. But we try to socialize it to find out if it actually also meets use cases of other people.
So it's a call to the folks in the group. So if you are aware of other initiatives elsewhere and sort of maybe make them aware of what we are doing, pull them into the group so that we have some information sharing, that would be fantastic. Yeah. And please also, like, this is a more general remark, but I I think it's also appropriate in this context. So when you, from a process point of view, when you when a document transitions from an individual ID to a working group document, you are, as the authors, you're kind of relinquishing control over the document to the working group from yourself. And so, like you put on your, Oliver posted a link to the PR that is quite elaborate on the proposal for defining this type metadata. Make the working group aware of it. Like, try to do your best to involve the group in bigger design decisions so that we don't have problems later on when people suddenly say, "Oh, it was never discussed," was basically done in a in some private club.
Yes, that's a very important point.
Christina said, I would expect IETF process to ensure that non-EU requirements are reflected. Yeah, of course, because of the transparencies and working group last call, IETF last call, etc. We'll definitely get input, but I think we also, since we are the experts in that area, and you particularly in the sitting here in the group, you have the exposure to some of the ongoing activities worldwide. Reach out to the people, try to establish the connection so that we can do our best to cover the different needs and make this more generic. I don't have any concerns specifically, but I think it's in general a good practice to do that. Okay, cool. Thanks, Daniel.
Thank you.
Okay, next one. I think you are on the next one too. Well, who's going to talk about this one? No, is it Tobias?
I will start with this one. Tobias and Paul, all three of us will be presenting.
Awesome. I will do the slide management, right?
Yeah, perfect. All right, so token status list, formerly known as JOT code status list. I hope we have now a better name and easier to pronounce, especially. Next slide, please. So a short refresher. What are we talking about? We're talking about the capability for an issuer of a token to communicate dynamic status information about a token. So during its lifetime, after issuance, before expiration. Next slide, please. So an example, what that can look like is we have a wallet. We transmit some kind of token. This token has status information that contains an index and a URI. The verifier parses that token, finds the URI, fetches the URI, parses the status list, and then verifies status information depending on the entry at the index. Next slide, please. I'll try to be really fast because I think we have to catch up a bit on time, right?
No, we are good. Brian made me aware that we had 5 more minutes than the clock on my screen indicated. So we are good.
Okay.
Yeah.
Okay.
So don't.
Yeah. So we had two versions, O1 and O2. Let's go through the changes of each of them really fast. We have some of them bold. These are the ones we will be presenting a bit more in detail later because these are bigger changes. And then later on, we also have some questions that we want to ask to the group. So I've already said it. We renamed the draft. We added a somewhat bigger design consideration to the introduction. So to say what we try to solve, what we see out of scope, etc. We changed the status claim to allow the reuse of the status claim for other mechanisms. More on that in the following slide. We have an IANA registry for exactly that now, or we are proposing that. We are restructuring this section. We think it's a lot more readable now after restructuring parts of it. We added an option to return an unsigned status list, so it doesn't have to be token. It can just be an HTTP endpoint, and you get a JSON or CBOR directly. We changed compression from gzip to zlib. This is a very minor change, but we felt that this is more natural. And then some minor changes like typo and adding an example as an access token, as an example use case. Next slide, please. And then in O2, we added a time to live claim to the status list token to convey caching information more directly. We will also have a slide on that one. We relaxed requirements on reference token. Perhaps a bit more context on that. So we also allow basically COSE sign 1 now. So for example, MDoc can use a mechanism. We had a small change in the formulation for the deflate zloop compression. It was not too clear how that works. It should be a bit clearer now. We explicitly reference the issue holder verifier model of SDJVC, because that kind of explains more of the overall concept of the specs as well. And we added COSE or COT CBOR encoding to the spec. So it's basically now the HOSE and the COSE world. Next slide, please. So let's go a bit more into the bigger changes. So first of all, we got some feedback, and we saw that during our implementations and discussions as well, that we kind of expect different status mechanisms to be used. There likely won't be the one status mechanism to rule them all. So we have to prepare for reuse. So what we did is, instead of having the status object directly convey the index and URI information, we went towards a mechanism that is similar to the confirmation claim, so CNF, where you have status, and then in a nested object, you have the description of the specific status mechanism. That will allow the reuse of the status claim in the long run. Next slide, please. Tobias, I think you're taking over now, right?
Yep. Thanks. Can you guys hear me?
Yep.
Just check. Okay. Thanks, Hannes. So really, this one's relatively simple, which is in order to provide a simpler option for consuming parties of these status lists, we've added an option to place trust basically in TLS rather than an application level signature. And really, I'd say this is akin in some ways to the unsigned authorization metadata option in OAuth 2, and also has some abilities around enabling status list repudiation. Next. This one's a slightly bigger change. So when a token is, when the status list itself takes the form of a token, we have defined a new time to live claim for both JWT and CWT generally, and we're making that ask in our draft to register that claim. And basically, when it's applied to the status list, it enables a way at the token level for a consumer of a status list to know when to check for updates. The main alternative that was considered was having an absolute timestamp for update checking, which was dismissed because basically it synchronizes refresher update requests for consumers if you have like a precise time in which the status list is going to be updates. And a TTL, on the other hand, enables communicate a reoccurring update interval instead of a single point of time without having to re-sign the status list when there's no updates, right? So the diagram down there attempts to sort of communicate that. Basically, you have a token that was issued at some time, then sometime later a consuming party resolves that status list, and then they can, from their time of resolution, apply the TTL to that time window to check for updates up until the token then expires. And the intent with this TTL claim is for it to only operate within the IET and EXP sort of boundaries. So that's all on that one.
Next slide.
Sorry, were there questions on that? Sorry, so the next change is we've formally added encodings for the status list. So some will be aware that prior to draft 2, we signaled that we were going to make the status list itself expressible in CBOR. And since as a part of draft 2, we've added the encodings. And this is a bit of a breakdown on the main. So down the bottom there, you've got the status list in CBOR format. Then you've got the securing envelope, which is the status list token, applying CWT. Next slide, I think. We have then the reference token. This is a representation in CWT. and diagnostic view, akin somewhat to the JWT representation as much as practically possible, with noting the differences between JWT and CWT fundamentally. And then lastly, as Christian said, next slide, we've also got the, if we just go back a slide, we didn't actually have that. What we've also defined is that for reference tokens that aren't themselves CWTs, where a ISO 18013 Part 5 MDoc is such an example. It is secured using COSE Sign 1, but itself is not actually a CWT, and would like to be able to reuse this mechanism. We've defined effectively the the CBOR data structure that would need to be embedded in such a secured structure for using this status list mechanism. And I will hand over, I think, to Paul. Next slide.
Thanks, Tobias. Okay, so what follows now is some considerations for the future and some discussions that we're currently having. First of it is that we want to provide a mechanism for verifiers to fetch a list of all status lists. You can imagine a police officer loading his device in the morning with all status lists, for example, for MDLs, so that he could use that for offline verification. And therefore, we need a way to know upfront which all the interesting status lists may be that a status list provider offers. And there's different options that are being discussed. It could be something that is working as a relative path, like a kind of a parent path to the actual status list that contains the structure. It could be placed in a well-known path or directory. Third option is we could add another URL to the status list claim in the reference token, or it could be in the issuer metadata, for example, in IACA file in the MDoc case, or in OpenID for VCI metadata. That would be some protocol or ecosystem specific. And the data structure that contains all these lists need to be defined as well. Next slide, please. Second discussion that we have is on identifier lists, or something that's most common now, most commonly known as certificate revocation lists. This was brought up also in the discussions that we have with ISO MDL folks that are looking into revocation. And also other people have come up to us now that we've introduced this status mechanism that allows other status mechanisms to use the same syntax. And CRLs are the oldest well-known example of revocation. So people are looking into this, and we get the question whether, if we want to add this to the status framework, does this belong into the status list draft as another side option, or is it better to start a new IETF draft for this? This is something that we would like to get feedback on. This issue is also a little bit time sensitive. Next slide, please. And third discussion is on the IANA registration. So now we're registering a new registry for the status mechanisms. That's working similar to the CNF one. I would apply both to COSE and COSE World. Question is, do we create a registry for each, like for both JWT and CWT IANA documents? And also a question is, does it fit in there if we want to use it for other things that are not JSON Web Tokens or Siebel Web Tokens? And do we plan to have 1 or 2 registries? And next slide, other open topics that are still open or being discussed. We need to be more precise and more detailed on the validation rules that will be added in the next one. We also need to add a little bit on security considerations, and we need to provide some more examples and have some small fixes, especially on the Siebel Web Token. And we also want to include an MDOC example. There is also a discussion whether the status object should be rather a header than in the payload. Another discussion is on the authorization for the status list. So every relying party or verifier that has seen the URI for the status list can fetch this today and tomorrow and whenever he wants until it is available. And it has been discussed whether we should give guidance on some authorization mechanisms there. We more of tend towards dropping these considerations from the spec currently. And as a last, also the feedback from last IETF in Prague was that people were interested how these different status mechanisms or revocation mechanisms compare to each other. We're thinking that this maybe does not belong into our standard, but it might make more sense to have maybe an informational RFC draft that does this comparison, and that could also include then comparison, for example, to status attestations or to a CRL or other mechanisms. Yeah. And that's it.
Okay, thank you. Any questions on this document? Ori.
Hello, Ori Steele. Thanks for the document. The comment about the header versus payload location is sort of interesting to consider. Just because, when you're looking at the header, maybe you're looking at metadata about the payload. Maybe if you check the status, you might even decide, I really don't want to look at the payload based on what I just have detected from status check. So I know, it's typical in OpenID and OAuth to sort of blend metadata into the payload and the header, but from a sort of designing modern security formats perspective, I like the idea of like looking at the header, making decisions, then looking at the payload from a design standpoint. So I found that comment interesting, and I wonder if it's is it well supported? Are there others who feel strongly about sort of an ordered processing of the secured information in credentials based on that? Thanks.
I can probably provide some really like a basic sort of response to that. One is because especially for when the reference token takes the form of a JWT or CWT in JWT and shortly to be the same in CWT through a mechanism that we've actually just standardized, there is the ability to have like JWT RFC says JWT claims can exist in both the payload or the header, right? And there is language and treatment for if they coexist and how that should occur. Because so what I'm trying to say is by registering a JWT or CWT claim for a reference token, I guess we are leaving it open through the underlying RFCs for where that claim might ultimately exist in the data structure. And I think for examples like SD, JWT, VC that would ultimately use this, I believe they're intending to use the payload. But I'll maybe leave it to others to comment to those pieces.
Just one quick reply to that. Like the CWT claims and header feature is for the CWT case. In the case that you were using the CWT claims and header feature, and you had CWT claims in the payload, you could possibly have status information in both of them. and that could also sort of be problematic. But I actually really like the potential for CWT claims in header with status information there, and then possibly also with selective disclosure in CWT claims in header sort of coming in the future, because the payload is often like, it's nice to sort of dedicate the payload to something that's application specific in some contexts. So yeah, I agree with what you said. Thanks.
I jump in just real quickly to clarify that the JWT spec is not that flexible in terms of including claims in the headers. It's very specific about the context and the meaning of their usage. So not to disagree with the overall thought process or anything, but you don't get that for free by registering it as a claim. It's geared, it has a totally different intent and wording.
Peter Castleman. First thing, just in terms of the not signing the status list, it would be good to have some security considerations to give guidance so that implementers understand the trade-off that they're making, right? It's an efficiency versus security type trade-off. It'd be good to have that. And then you had a second, I just want to make sure I understood correctly. It looked like you were asking a question whether the scope of the document should be expanded to include other types of revocation mechanisms like CRLs, etc., or CRL-like systems. Did I understand that question correctly?
Comparison. Sort of a comparison with other mechanisms.
Oh, as a comparison, not including additional.
Yes.
Okay.
That
Thank
was
you.
two different things. Sorry. One part was that we should have a comparison of the different overall mechanisms, and the proposal was to have an informal RFC for that, something external. But the question came up, for example, if we have something like a CRL, but in CWT or JOT format, where would we put that? Is it a new draft, or should it be an additional mechanism in this draft? We were kind of favoring a new draft, but that question was also brought up to us.
Thank you. My view would be a separate draft, just to keep things clean. That would be my recommendation.
Christina.
Good transition. I was actually on the same topic. I was actually thinking more towards the same draft, in the sense that, at least personally, I was hoping that, this status list draft would kind of be, OSA shelf, interop option, like a stage.vc kind of sense. But that is not the direction draft has taken. Like right now, the draft defines an extensibility point, which is a top level status claim. And, because this draft defines that, I would, at least if the difference is kind of the content, whether it's, CRL style kind of registration of the, credential ID versus the compression like gzip, like the current approach. If that, it feels like positioning that as two different ways of how the status claim defined in the spec could be extended. Like I would hate to have to point people to two different places if it's extension of the same mechanism. So yeah, it sounds like we need more discussion, but those were my intuition, at least right now.
Nick.
Nick, Center for Democracy and Technology. I've recently reviewed a similar specification in W3C, the bit string status list, that I think has some similar properties and some similar quite serious privacy threats. As you note in the spec, there's the threat of a malicious issuer who gives out different status lists to different holders, such that the issuer can, to some extent, create a phone home property where they can see when and where a holder presents a credential. And that doesn't have to be solved right now, but I am curious if there are mitigations that we think can be deployed, because that's rather a catastrophic risk for many of the users of this type of technology. My initial concern is that the relying party or verifier is not the one that we would typically want to count on, and I'm not actually sure that they could even detect that this is happening.
I think that the behavior of a malicious issuer in this case is very probably easily detectable by a relying party that has a medium size of credentials flowing in, because he can compare the number of different URLs to the amount of credentials that he has seen. And that should be a pretty good metric to spot that issuer is doing malicious things. So it at least is kind of easily detectable. Whether this actually happens, I can't say. But it is a threat that we've also covered in our privacy considerations section.
Right, I see that. It seems like the issuer can add dummy values and things to, and unless the relying party also knows how many people there should be, and like has some detailed information about the entire population of credentials from the issuer.
Yeah, so I think just to sort of comment there as well, Nick, like there is more work for us to describe some more mitigations there, such as, you know, relying parties being able to, based on the herd size of the status list, and then to Paul's point, the number of status lists that are available from that issuer for that kind of credential type. And then it does then create a relationship to, well, do you have information about the size of the credential herd? Because that then allows you to sort of understand whether or not the number of status lists makes sense in the context of the credentials being issued. So I think there are some recommendations we can describe to make detection somewhat more transparent for relying parties, but there are kind of just different trade-offs, I guess, when it comes to how these status mechanisms can reliably shield from different threat models, such as a malicious issuer.
Okay, thanks. I would love to keep working on this because it seems like it's going to come up in multiple settings, and I think the risk is quite severe. Thank you.
Thanks. Ray, you one last question.
Yes, Ray Letts. I'm new to this discussion. On this, I have just a couple of comments that may be useful. Offhand, I didn't see any error detection and correction of these bits. It seems very fragile. You get the index off by 1 and you're going to get a wrong bit. So this I would say I'm in an auditing field and so forth, I would consider this a very fragile protocol because it is easy to break. You get the indexes off, you're a little bit of stale indexes, you don't know what the bits are. And I don't see the error correct or the detection of check bits on that list, but maybe I don't know enough. Thank you.
Yeah, if you use a digital signature, you would be well protected. If you don't do that, there can obviously be
Well,
some.
it looks like they cache the indexes. They're supposed to have that, and then
Well, they have now added the mechanism to an unsigned version, which of course can get corrected as it gets cached. So that may be actually a consideration to think about, because cryptographic signature is obviously a good error correction or error detection, not correction mechanism.
Yeah, thank you.
So that's I didn't think about that. But it seems that we have a couple of things, or you have identified a couple of open issues, which I think we need to work through. So, so that's excellent. I have some thoughts about some of those points, but we'll discuss them on the list. Do we have some reviewers in the group? I think this would be like we are now at a, I would say, halfway stage in this document, and having some more eyes on this would be useful. Anyone in the room who would volunteer to do another review of this version, which has seen a couple of updates? Nick, you are going to do a review?
Sure.
That's perfect. Please note that Nick is going to do a review. Thanks a lot. Okay. Next topic. Give me a second. Yeah, at the last IETF meeting, we said that we would, among a couple of interested parties, do a conference call and chat offline. Of course, we were time flies, and we're guilty not to do that. So apologies for me failing on that. But I hand over to Tobias and Paul to talk about the document.
Thanks.
Yes, sorry, Hans. I think we're as guilty as you are on this one. There have been lots of things to do. We made a lot of progress on status list. Unfortunately, we made a little less progress on the attestation-based client authentication. But there's a number of discussions that are pretty important for the way forward that we want to discuss today. So less progress, but more of discussions currently. Next slide, please. So yeah, a little recap. Why are we doing this? We want to do client authentication for clients that are or have been described as public clients. The motivation for these is also mostly coming from the verifiable credentials ecosystem, where clients are probably native smartphone apps, and we have mechanisms like play integrity or app attest, the device check on iOS that may be used to authenticate these clients, and questions how can they be used in OAuth, especially in the context of verifiable credentials or IDAS. Issuers of credentials want to make sure that they are talking to the correct wallet, and so they get some assurance that some regulated use cases or high assurance credentials that they want to issue land actually in the correct wallet, and they are protected. They're using hardware-bound keys, kind of these things that you need for regulated use cases. Next slide, please. These slides are building up very slowly for me. Okay, so progress update. There have been only minor additions since IETF Prague, mostly because there have been extensive discussions, especially on the GitHub repo. Two things that we want to discuss today in particular. First one is a proposal to use depop for the proof of possession syntax of the client attestation. The second one, also related to Johannes, in the feedback that we got from IETF in Prague last time, is that this mechanism that we have been defining as a client authentication mechanism that's mainly used at the token endpoint, people said they may want to use that at other places, at other endpoints. So second proposal is to support a header-based syntax to use, yes, this attestation-based client authentication method, for example, for DCR. Next slide, please. So I'll show a recap of what the last or what the current status quo of the draft is. We have an example of a token request here. And we provide the authorization code, and then we have the client assertion type, which is using the client authentication framework, RFC 7521. And then we have defined the client assertion here in green as a concatenation of 2 JSON Web Tokens. The first in green is the client attestation. So this is something that is issued by the client backend that's assuring the authenticity of this client. And in this client attestation, there is a public key that is controlled by the client instance, and the client instance then will add a client attestation proof of possession in orange, and they're connected with a lovely tilde. This is the status quo currently, and the authorization server will check the green client attestation. We'll see that this belongs to a client that he trusts. You will check that the public key matches to the public key in the client attestation proof of possession. Next slide, please. So yeah, this is how the current draft will look like if we would use also this together with Depop. So we have additionally now here the Depop header, and from the use cases where we envision this, it kind of makes it seems natural that there might be a Depop header, or to say likely that there is a Depop header, because we usually will use the client authentication method if we want a high assurance for this client. And then it makes sense that we also have an access token that's not just an bearer access token, but also a sender constraint access token. So yeah, could we do better and combine these kind of things? And this is where I hand over to Tobias.
Paul, I think we have a question from Usama in the queue. Usama, do you want to comment on this specific issue?
Yes, please. So it's more of a question. So on the last slide, you mentioned client attestation, and I'm wondering if it is what you meant here from the RAT's perspective is, I think, the evidence. Is it correct?
Yeah, so the terminology between RATs and OAuth client attestation is kind of absurd, mostly because we also come from the verifiable credentials ecosystem where the verifier is something completely different from what a verifier is in RATs terms. We also have an open issue to kind of make a translation between RATs terminology and the one that we're using in the OAuth and ecosystem. But I believe
but
so,
this is,
yes.
I mean, this is independent of the very.
Yeah, Usama, to answer your question, I think in this context, this would be the attestation result, I believe.
Okay, yeah, that's what I wanted to just clarify, because evidence and attestation result, it could mean anything. So it would be nice to have the terminology synchronized with the RAT's perspective. Thanks.
Yeah, Justin? Okay, it's on a different issue. Okay, perfect. Yeah. Yeah, it's this is a to be done. Okay. Paul, do you want to continue here on this slide?
I'll take over from the next slide.
Okay, now I have another. Tim? Okay. We'll just continue and then have the queue.
Okay, cool. So we've identified that many of the use cases, at least when this draft was first conceived, which about a client authentication mechanism, and we'll cover some of the broader cases around ECR usage and those sorts of things later on in this slide deck. But for those use cases, we expect that this will be used with Depop bound access tokens, and therefore the need to make this work well with Depop we think is quite important. Depop already defines a fit-for-purpose proof of possession syntax, including nonce management, which our draft is effectively reinventing. We also realized through some contribution from some of the editors from Depop that the Depop proof of possession syntax can actually be reused without requiring the AS to issue a Depop bound access token in response, because that is reserved for the AS to make the decision. Even if there is a Depop header in a token request, it doesn't necessitate the fact that the client will get a Depop bound access token in response. And then the draft, we believe this draft is actually really useful in the context of Depop to address something that was out of scope for Depop, which is the ability to authenticate the Depop key back to the client. So I filed issue 69 with a case to sort of describe that more. But basically, with this mechanism in play and the proposal we have, you would be able to authenticate that the Depop key is appropriately authenticated by the client. Next slide. So this was another one that was raised in the last IETF meeting at Prague, where some people were also asking, well, I could quite like to be able to use this attestation mechanism in other places other than just for client authentication purposes, such as I may want to present this attestation towards a resource server. And also, I may want to use this attestation as a part of a dynamic client registration request. And in order to sort of do this, we considered whether or not we could shift this attestation information out of being present in, say, the token request, but instead into headers. Next slide. So this is really a proposal based on those kind of two observations. So you'll see now that the client attestation POP would be in effect conveyed by the Depop POP in a header, and then we would have a new header which communicates the client attestation. And so you've still got the relationship between the client attestation and the client attestation POP, but they're conveyed through a header instead of through payload elements as defined through RFC 7523. And then lastly, down the bottom, which is still something we were considering, is this client attestation assertion type could be present if you were using the attestation for the purposes of client authentication. And it's a separate concern about whether or not we would define that or whether or not we would consider attestation differently. You know, the current view is we do think that this fits the client authentication model, but perhaps not exclusively. Perhaps there are other usages of this attestation scheme for purposes other than just exclusively client attestation. So, sorry, next slide, please. So the discussion for the group that we wanted to sort of feedback to this working group is that the trade-off with this proposal is that the Depop key and the client instance key must be the same in this proposal, which can be viewed as both a useful simplification and a constraint depending on perspectives. And we wanted to ask the working group whether or not they have an opinion on this. Are there practical use cases where the Depop key and client instance key need to be different? Or does the complexity it create is kind of more hassle than it's worth? Because if we sort of remind ourselves of the proposal that Paul introduced, which is when this draft is using with Depop, we would in effect get 3 signatures in, say, a token request, a Depop, when you're using this mechanism with Depop bound access tokens. And just calling out that this issue is relatively time sensitive, given an interoperability event in late April. Kind of want to use this draft with Depop as well. So if we don't optimize this, it'll be a much more complicated implementation path. With that, I think there's a queue forming, so I might.
Yeah. I was about to say that the queue is building up, so I think you touched on a few interesting points. Justin, let's get started.
Hi, Justin Richer. First off, yeah, client attestation is not client authentication. Just full stop. It's not. It's a different thing. And it needs to not be crammed into client authentication, not only because we want to use it elsewhere, but semantics are important. And we should be making a strong statement here about when we're presenting this, that we are talking about something that is working at a different plane of existence. And I think that the separate header proposal or something like that that would capture this separately would go a long way to addressing a lot of the concerns that I have in this document. Except for the other concern that I have, and that is that we're getting several different efforts that are putting squigglies in our JOTs in order to tie them together. And I just have a really bad gut feeling about that. Somebody's going to cram one of these defined objects into an SGJOT parser and have some weird collision failure thing that we haven't anticipated yet. I don't have an attack like that in my pocket, but we're coming up with similar syntaxes to say, no, this is different, but they look really similar from a lexing perspective. And that's usually a recipe for things to go wrong.
Yeah, so can I just also ask there, because this proposal that we put on the table wouldn't involve a squiggly, because we would have two separate headers that become related together. And could I just ask if you had any feedback on whether or not you reusing the depop as a proof of possession syntax rather than a separate header like this, separating the client instance key from the depop key, whether or not you think that is a good or a bad idea?
I would need to read the proposal before having a proper response to that. But like depop is really meant to be instance keys. And I think that trying to reuse the depop header for something that's actually not asking for a depop token or doing a depop possession is a really bad idea. Whether we reuse the presentation syntax and put it in a different semantic context, that's a different thing. You know, there's a lot of ways to kind of cram this type of information into an HTTP request, but I would not use the depop headers unless you're actually doing depop.
Brian.
Counterpoint to that is that the depop header itself is for proof of possession of an instance key. This is also wanting proof of possession for an instant key. And the depop mechanism itself defines this nonce exchange that is currently under-specified in the construction here, and is going to be kind of a pain to re-specify through this and include duplication. Using two different headers, whether it's depop or not, does address your squiggly concern. So I think it would go towards that direction. I have a bunch of different notes. I'm sorry, I'm out of. And back to client authentication, I understand why all this is structured on and built on top of 7521. It kind of makes sense, but it's really not actually necessary. So even if you wanted to use these two new headers for client authentication, you can define a client authentication mechanism straight up using the headers and just say that's how it does. So even though I was involved in 7521, I love to see its legacy lived on. It's actually not needed in this, and I think you'd probably be better off just to do the headers. And if you want client authentication, just say this is the, I don't know, whatever you want to call it, but you don't need to try to reuse the assertion framework, and that could simplify some of that structure you had at the bottom there. Yeah, I think that's all I got. Sorry, thanks.
Thank you.
Oh, thank you, Justin Richer, and just wanted to question if it really is an instance key in the same way, because like a key that's been attested to by a party versus a key that's being presented as like use this for the next step, I think are saying different things. Now, if we dig into this and agree that yeah, they really are close enough, we should use that, that's fine, but this needs to be a deliberate decision that we make and not reusing convenient syntax. Like I get it, depop does a lot of great stuff in making that work, and reusing that structure where we can makes sense. I caution us on reusing the semantics in a way that doesn't map as well.
Good thoughts. Yeah.
Yeah, I think that maps directly to the first question here about the trade-off between the two.
Yeah.
Yeah.
Aaron.
Yeah, hi, Aaron Baraki. Geez, I'll try to be quick. First, thanks for listening to all the feedback on the previous discussions. I really like the header approach to this. I actually had written up a header like this in my notes for this session, so that's great that you came to the same conclusion. I also agree with avoiding swigglies. Just wanted to put that out there. On the duplicate or the depop key issue, I agree that if it's not actually a depop key, it probably doesn't make sense to use a depop header. One, because overloading stuff is not usually a good idea, but two, because if somebody is expecting to process the depop header for depop in an endpoint already, and then they're now trying to layer this on for a new use case to an existing system, now you have to treat the depop header meaning two different things, which is gonna be a mess. So I'm trying to think of this as, you can get away with a lot of stuff if it's a greenfield deployment, but when you're trying to go in to an existing system and add this layer, then you end up with a lot of these weird situations. So I would rather keep it clean. So if the instance key really is depop key and it's used as depop, then great, you can use the depop header for that plus the attestation header. If it's not really a depop key and you have a separate depop key, then you could even add a third header, which is the attestation pop key. I don't remember the name of it now, but like there's no harm in if you really do have two separate keys for it. At that point, you might as well put that extra proof of possession in another header instead of a squiggly, right? And then you keep the depop header clean for depop processing. Yeah, I think that was it. Thanks.
Thanks, Aaron.
As we switch over to Christina, I want to caution to think that this is really greenfield because you have to rely on existing attestation technology to make this meaningful. So, and there's some sort of nuances with each of those technologies. But Christina, go for it.
Yeah, super quickly, basically +1 to what Justin and Aaron has been saying. Just wanted to go on record that reusing the same key for depop and this client attestation does feel like a very specific scenario, which shouldn't be forced on everyone. And partially building up to what I think Aaron said, there are implementations for using only MTLS for token binding or no token binding at all, and forcing those implementations to process a depop header doesn't make sense to me and feels like overload. So I hope like this topic keeps coming up. So I hope at least the depop topic we could, like agree on a direction finally.
Perfect.
Yeah.
Yeah. Sorry, we ran totally out of time, but great presentation. You raised a lot of issues. I hope our note taker was able actually to catch up, looking at him, and he's kind of shaking his head a little bit. Yeah. Okay. Thanks, guys. That was really great. Now, Ori, nonce, endpoint, and status attestations.
Hello. Hello. I'm Ori Steele, and I'm my co-author Giuseppe. Oh, thank you. Is with us in chat, and hopefully he'll interrupt as we go through this. We've got two documents we're going to present back to back in the same deck. There's a connection to them. We can get into that. Giuseppe, anytime you want to interrupt, just go ahead. Wish you were here. I'll try and make big hand gestures, I guess. It's like, I don't know. That's awesome. So let's get into it. So why the nonce is important. So there's lots of cases where you need these. You need a unique one-time use number or string. It ensures that each transaction request is unique, protects against replay attacks by making each request verifiably unique. And I think you've already seen several presentations today where a nonce is a important part of those interactions. So what's the nonce endpoint? It's an endpoint. You get a nonce from it. It's a lot of text, but this is basically what it's saying here. So it's a RESTful endpoint for issuing nonces. And we could get really hung up on what exactly does issuing mean. Kind of depends on what kind of opaque string or number you're getting. It's usable in OAuth 2 and any other protocols that require issuance of nonces. And this is, I think, a really important point of the design of this document that I like personally, because it's a very simple document. It does one thing, and that one thing is useful to many other things, including OAuth. So this nonce endpoint could be protected, could be unprotected. Obviously, unprotected HTTP endpoints that serve important information have special security considerations we'll need to think about. It overcomes integrating the provisioning by error pattern, which we see in specifications like Depop, basically. I'm not sure if there's other protocols or specifications that kind of make use of this pattern of I'm presenting something to you, and it was important that I have some freshness proof, some nonce as part of this. And my way of delivering this to you is you just give me something that is going to give you an error back, and then I use the error to hand you back the nonce that you will then use to complete a successful transaction. So there's a little bit of a sort of API design aesthetics taste comment sort of hidden in this piece. We can definitely discuss that. And it can be used with public audiences for internal infrastructure as a microservice. So deployment comment. So what does this nonce endpoint do? Well, I've basically said it several times, and hopefully you were imagining something that sort of looks like this. So on the left-hand side for me, you can see there's a get endpoint that has no query string parameters, and it's returning a simple nonce, and it's the nonce is content type application JSON. You can imagine maybe you negotiate for something other than that, I suppose. And then on the right-hand side for me, you get query string parameters, scope, pizza, and audience, Mario. These are not choices that I made for this example, but I think they highlight an important property of nonces, which is that they're always requested and used in some context. So, how do you communicate that context? There's lots of ways you could do it. We were just talking about HTTP header parameters. That's another place where you can shove a bunch of context into a request. So when is it the right thing? When is the right time to use a query parameter, and when's the right time to use a header parameter? And we could get into a longer conversation around that piece, but I think the important part here is like two of the pieces of context that are really important to consider when you're thinking about a designing system for nonces is what scope and what audience. So why do it? Well, I've mentioned this cleaner API motivation scenario. I mentioned there's many other protocols out there that want a simple nonce endpoint that they can just plug into their part of the protocol where they need to be able to provision these nonces and then achieve them. The nonce design considerations can be useful for considering these privacy and security issues. Not just for all of these different cases, like when would you want an encrypted nonce? When would you want a signed one? When would you want a uniform at random one? When would you want MAC-based one? Like there's all kinds of different design considerations that you might use in the construction, and being able to think about that in a really simple document. That seems like a good thing that we can actually get into some depth around that, because the document's basically just about one thing. And protecting nonce endpoints, may be an opportunity to create new flows. Giuseppe, I don't know if you're available, but I might ask you to expand a bit on this last one. I'm not sure I fully understand the thought process behind this, other than nonce endpoints are often the jumping off point for a particular interaction in a given context. Welcome. We have your video. We don't have your audio yet. We do not hear you.
No, we don't hear you.
No.
Okay.
Very low. So, well,
There you
it's
go.
quite late in Italy. Everybody sleeps at the. Well, can you hear me now?
Yes.
Well, the last point, yeah, is something that opens the opportunity, since the nonce endpoint is just an endpoint outside of any monolithical view or implementation. You just have the nonce, you can serve it protected or unprotected. So considering that this endpoint might be protected, well, we may have several new flows, several new opportunities, several things. It's just a piece that can be used in different contexts for different scopes, even outside of the current implementation we made in Italy for the wallet ecosystem, in particular between the wallet instance and the wallet provider. Probably this won't help the discussion already. So,
Yep.
Anyway,
I understand now.
thank you.
Yeah.
Thank you.
Thanks.
I had one question, because you were saying it can be used for all sorts of purposes, but the concept of a scope and an audience is something that is OAuth specific. And for example, like here you say it can be used for rats. Rats has some other needs. For example, some attestation technologies require nonces to be of specific size. So you need to pass information in about either the size directly or the information about the attestation technology. And so like there are subtle differences between the way how security protocols use nonces in different applications. And I think just saying, oh, I just use a nonce is apparently is like, as is, I couldn't use it for rats.
Yeah, I think that's true. Kind of piggybacking on what Giuseppe was saying on the protecting the nonce endpoint, it opens opportunities to create new flows. Some of the ways in which you might protect the nonce endpoint could be part of what enables the nonce to be used in some of those other flows. And scope and audience, I don't think of them as being limited to OAuth. I think of them as concepts that are echoed in protocols that need that and that have a concrete, instantiation in OAuth, but that you see initial, used in other places as well. I think this is what's dangerous about this draft, is like imagining kind of an abstract concept of a nonce, and depending on how you delivered a document, you could get into a lot of trouble with that. So I think there's risks associated with it, but I think a well-designed document, there could be a lot of benefit as well.
Ray.
This looks a lot like the NIST randomness beacon service. And that was actually pretty hard to design, such that the random numbers could not be, generation could not be infiltrated. You had to have a couple of different ones, and they had to be, so actually designing a random number generator that would be a service is not, so I would recommend looking at that. That, if for people that don't know, generates a random number every minute or something, or a second, and you can go and get it. And so you can say, let's use a random number at this certain time. And then you can both look at it and see it's there. So anyway, it is what you're talking about here, I think, is sort of a non-trivial thing to make it be secure. Thank you.
Can you post a link into the chat window?
Yes.
Good.
Thank you.
Peter?
Peter Castleman. I have a couple of observations. One, this feels, I'm not entirely sure how I would necessarily use this nonce service, because it's often useful to have that nonce in the context of a transaction having an extra endpoint to go call, etc. Right? There's sort of efficiency issues that we run into. So it's not quite clear, but I do wonder if there is perhaps a desire or a benefit in having a document that describes how to generate good nonces. And that may already exist in other forums, but maybe that is a thing that is helpful to protocol designers, is here are ways in which, how you should think about a nonce in terms of a good design. That may be perhaps, I think the desire here is, hey, let's set up an endpoint and now you can get good quality nonces and you can use them in different places, but maybe just giving guidance on what a good quality nonces might be more useful. Just a thought.
Yeah, thank you. I mean, the objective is sort of twofold. Primary objective is actually to do what you're saying, which is give guidance on generating good quality nonces for use cases. Secondary objective is to give at least one easy way to access it for protocols that already have HTTP sort of as part of them. Brian.
I wanted to maybe just provide a little bit of defense or counter argument to the no provisioning by error. Like some of the existing nonce, and actually the only nonce that's really in OAuth level protocol right now is provisioning by error, but you can also think of it as like a more typical challenge response mechanism that's delivering the nonce in the context of the request that you're actually needing it for. So
yes, it's like you're kind of in those scenarios, you're sort of hijacking the context that's coming in from the caller and using it as part of the scope mechanism, and then handing back the nonce that they need to satisfy the request. So you're saying,
in line, in context of the transaction,
right.
Challenge response, and there's also mechanisms to deliver a new nonce in the context of a successful transaction to continue doing it. So,
and that's not provisioning by error. That's like this request succeeded, and here's your next nonce.
Yeah, so and they're kind of combined, and it's not the prettiest thing in the world, but it's also not, I don't know, maybe as terrible as it's being portrayed in this.
Do you want me to say worse things about it?
Sure.
No,
it also exists, and it would be difficult to, I think, potentially difficult and confusing to try to reconcile it with a new mechanism for obtaining nonces.
For protocols that are bound to HTTP that are doing Depop, I don't think this is a replacement for them. I also think Depop being bound to HTTP caused other problems, and so I think it's worth considering a modular approach here. But I agree with your point. All right. Did we join the queue?
Two more,
no,
Justin and Mike, and then.
Justin Richer. So I can only speak to my own limited experience in ignorance, but this makes absolutely zero sense to me to exist. The whole point of a nonce as built into just about any protocol is that it sort of inherits the context in which it is presented or generated. This is taking a self-asserted context and saying attach the nonce to that, and then hope that that context is still true somewhere else. Additionally, as Brian was kind of pointing out, nonces get generated by multiple parties. Would we expect a client and an AS to call an independent nonce endpoint to get the same nonce? And how do they reconcile that? Because in some cases, like we're going to have client and RS applications that are generating their own bits for themselves versus for others. Like where's the good guidance for doing things like that?
Yeah.
But ultimately, it's the divorcing of the generation from the context in which it is meaningful that really worries me about this. I think that this is an exercise in premature abstraction, and it's going to be a net negative to protocols that are built on top of it. I do not think that we should be doing this.
Thank you.
Mike.
Ciao, Giuseppe. I'm responding mainly to a comment that Brian just made. There is another context in OAuth world, which is when you're using OpenID Connect on top of OAuth, the OAuth client, AKA the Connect RP, has a parameter in the OAuth request called nonce, that it provides a nonce to the authorization server, AKA the OpenID provider, which is echoed back in the ID token. And that nonce comparison at the client, AKA the RP, is used to prevent substitution attacks that otherwise would be feasible.
And if I'm not mistaken, that mechanism is also used by like OpenPubKey and other extensions that are built on top of sort of cleverly reusing protocols that weren't originally considering what the nonce would be. I don't know if anyone here is familiar with OpenPubKey or some of the other code signing sort of use cases for clever reuse of OAuth protocols, but it does happen.
Believable. I'm not an expert in that. Thank you.
Guys, I was actually like, because you have way more to talk about, like the real thing.
You want to kick us along?
Yeah, like Aaron and Brian, is it okay if we advance and then, because I want to make sure that Ori gets through his
Both
deck.
of them. Yeah.
Okay, let's, Aaron, can we postpone this for a second? Okay.
All right. So what's the status of the document? It's a 0-0. So I'm glad we're getting great feedback here. There's been discussion with other groups, particularly Skit has use cases where it needs to, the Skit sort of HTTP API for interacting with a transparency service needs to have a way of provisioning nonces, and it doesn't really make sense to use Depop for that. But maybe it does. We'd love to talk with folks about that particular use case offline. Rats had a discussion about nonces. Hannes is sort of aware of it. I don't think the current document is a drop-in thing for that use case, but there was some good discussion. It's fairly straightforward, but I want to echo what Justin said. This could just be like too abstract and not fitted to a specific protocol use case. And, I still think that giving good security guidance on designing nonces in a simple document is a win for everybody. But maybe the HTTP part is a loss for everybody. Could be. It'd be good to chat more about it. I'm going to keep going now. So next steps. So as I said, we're encouraging the use of this particular endpoint beyond OAuth, since it's not particularly bound to OAuth. I also mentioned there's other cases where pieces of OAuth or OpenID Connect get used in other contexts. Interested in support for multiple payload formats, not just JSON. You probably know this. I'm not really a huge JSON fan anymore. I was before. Now I'm kind of like a CBOR fan. So I'd love to see the CBOR and Cozy sort of variant versions of these, and they're smaller. Yeah, and then security guidance around random nonces, signed nonces, encrypted nonces, and then encrypted with what, signed with what, all of those fun security guidance around relatively simple concept, but we can kind of go deep if it's a small document. Use cases, we're going to talk about one of them in a second. The architecture sort of layering strategy, the monolith versus modular comment, new direction. So it's an idea, keep throwing rocks at it. That's super helpful. That's it for that document. Giuseppe and I are also on another document, which I'm here to present back to back. Do you want me to just go? All right, I want to make sure I get through all the time. We have another co-author on this document, Francesca Mariano. I'm probably doing terrible on that name. I apologize. Hopefully you're here with us in spirit. All right, so this is OAuth status attestations. It would have been good to actually maybe even flip the order of this, since you're all just now so aware of what the status mechanism is and the use cases for the sort of bit string status list in quotes, which is really what the indexed status list that we just looked at is doing. And so this document is conceptually providing a similar mechanism in credential state, but it's different from like a CRL. It's more like OCSP stapling. And we're going to kind of get into those details. And of course, it has the word attestation in it. I'm not responsible for OAuth and RATs failing to align on the use of the word attestation. Next slide, which I can do. So what's the status attestation? So it's a signed artifact like a JWT demonstrating the validity of a credential, ensuring it hasn't been revoked or expired. It's issued by the same issuer of the digital credential, or and so basically this part right here, if you think about the document that you just looked at, where you're as a verifier, I'm calling out fetching a resource that is a list of many different statuses for many different credentials. Imagine a version of that where that verifier was forbidden from making network requests to arbitrary websites. The holder instead might have done that, and the holder could have presented that status list directly to the verifier. But the problem would then be the holder is presenting statuses for many credentials that aren't relevant to the holder and their credential. So then imagine that you collapse that all the way down to one, just the status attestation for the credential that's relevant to the holder. That's sort of what this is. And it's sort of, the nice feature about it is this basically inviting verifiers, like, don't make network requests to get status lists over the network. But as I just said, you can still use the status list when a holder presents the full status list directly. So this is, it's also just sort of a simplification of conceptually what's achieved for credential presentation with some dynamic state made by a holder. And what I like to think about for this is, like, it's really just about dynamic state and offline presentation. That's what this is about. And that offline presentation piece is important. The simplification around not having a verifier make a fetch request to get state, that's also an important characteristic. Right, so I've been kind of getting into the details around this. So this enhances privacy piece, like Nick was challenging on the last presentation, in a bit string status list of some very large size filled with dummy values, where the dummy values are twinkling in some way. There are channels that are available in that you can encode information. And so it's just a slightly more complicated assembly of information, and you have to consider the privacy implications and the honest participation of the protocol actors and all of that other stuff. From a security standpoint, I like to design something where, like, if there's a channel that can be a covert channel, I like to, like, call it out and then, like, say, are we okay with that or not? And so this approach kind of gives us a different way of thinking about presenting dynamic state as a holder for a given credential. But because the holder needs to obtain this attestation at a regular time interval from the issuer, so that, I get it this morning, and when I'm later, buying coffee with my digital driver's license, they'll hand me my coffee back, and they know that the license isn't revoked. Maybe I got it in the morning and I presented it a few hours later. The issuer is sort of able to control that time window for refresh on the status attestation. And if I make that super short, I'm kind of like planting an auger in the ground and connecting that to the holder. You keep coming back to me to prove your status isn't revoked, right? So it has the validity period of credentials and dynamic state about credentials have an impact on privacy and traceability of credential subjects and holders. So this has applications that are beyond just like personal human credential use cases. You can do this for legal entity documentation, supply chain, trade documentation, devices, smart cars, like all these other, non-person entity credential use cases where you might be maybe more okay to have that trade-off between the validity period of the credential and the dynamic state associated with it. And I mentioned the offline presentation use case. I hope that's obvious, but I'm happy to talk more about it. Let's take questions.
Okay. So, like, from the presentations today also, I'm getting the impression that to a certain extent we are re-standardizing some of the BCAC's mechanism for revocation and status of the credentials in JSON plus CBOR format.
Yes.
And the question is like, CRLs were mentioned, status lists have been proposed in the past for X509 certificates. Now we have this one which mimics OCSP. Maybe you have a version of OCSP stapling. And like, how do we want that? Like the question to be like, if we
can we stop ourselves from doing it?
Well, like having a being aware that we are doing that and saying we want to do that. I think that would be an important takeaway for Refat and myself in terms of sharing and managing the expectations and also reaching out to the community who we have existing community in the IETF, obviously with a lot of experience in deploying that technology. So we could actually leverage some of that experience.
Agreed.
Hi, Monty Wiseman. I'm going to speak up this time about the terminology, and I think Justin's right. Terminology is right. Let's not overload the term attestation. I think it's confusing enough. I'll be giving a tutorial on it in about 15 minutes, just to advertise that. But I don't think this is attestation in my realm and definition of attestation.
Give me a document that sorts this out between OAuth and RATS. Somebody do it, please. Not me.
It's a good work project. Thank you.
I agree.
John.
John Bradley. Hola, Giuseppe. So I like the idea of validity stapling, whatever we want to call it. The thing is, if the query by, let's say, a wallet to get the thing that says whether or not it's valid, when it's presented to the verifier, if the verifier, like if you have a colluding verifier and issuer, and the verifier has enough information to also query the validity, we haven't actually achieved anything. So,
yeah.
So unless we come up with a way of blinding the ability for the verifier to query the validity, I don't know that this actually buys us much. But if we can actually have a way of blinding the verifier to be able to directly query, I think maybe there's something to it.
Okay. So I think the one comment I would make is like oblivious HTTP obviously could be used in the fetching case for the other status list mechanism that supports fetching. And this one, you also have a place where you could put OHTTP if you wanted, but you're going to be passing basically proof of possession of a credential that you're requesting a validity, updated validity information for. So you're going to end up removing some of the purpose of making things oblivious in doing that, whether you're getting other network advantages. We could talk more about it. Yeah. So this is kind of what it looks like. You saw in the previous presentation, they had taken this confirmation claim sort of type approach. So here's a status and here's a status attestation. They had a status and then they had a status list. We can be friends. We don't have to fight over which status list mechanism is better than the other. There's a space for both of us inside of the status attribute, regardless of whether you do JWT or CWT. This is what we were just talking about, like how do you get one of these things? And this is a place where you might need to have a nonce in order to participate in some Depop flow. And I'm not a Depop expert. I'm actually just here presenting because Giuseppe's not here. And I care about the use cases for this in CBOR credential space, but you guys are the how to use HTTP well and with credentials pros. So, and this is a straw man. This is how holder could request the status attestation. They're basically going to make their request and they're going to pass their credential proof of possession for their digital credential. And that's how they're going to get their status attestation, and they're going to be able to staple that into their next presentation to prove, I have a authorization to transport this truck of goods across a border, and it hasn't been revoked because of some change within my supply chain partners within the last 5 minutes. That timing information piece is really important for these use cases. So you may require some newer information than you were certified 5 years ago.
Okay, Paul, we ran out of time here, but I quickly wanted to ask the group about on how many people have read the document, just to get a sense of where we are with this. This is new stuff, but we have been working on the status list for a little while already. We have been talking about that sort of whole problem space. So let me ask, how many have you read? Have you read the status or the attestation? What is the name?
OAuth status.
The draft.
Attestations probably needs a better name.
This draft.
Yeah.
Okay. Well, it looks like just from the count, I think it would be good to, or I would like to encourage you to take a look at this document. It looks like the whole problem area is interesting and relevant to the work both in OWASP for these VC-like type of things, but also relevant for SPICE. And so have a look at it, make up your mind, suggest maybe provide some feedback on the list about the design approach. I'm sure you have opinions. And we see how we take it from there.
Thank you.
Cool. And then we had one document that was sent to us called JSON fine-grained access. And Jinglin, you are going to present.
Hello, everyone.
Hi, we can hear you.
I'm Zhang Liang, an IT development engineer representing China Unicom. It's my first time attending an IETF meeting, so I'm really excited to be here and looking forward to learning from you all. Let's begin with the look at slide, which outlines the main objectives of our discussion today. The title of our document is JSON fine-grained access. Firstly, let me introduce the significance. Traditional access control methods, such as role-based access control and attribute-based access control, although protecting data security to some extent, gradually show their limitation when dealing with complex and dynamic data access requirements. To address this issue, this paper proposes a JSON-based fine-grained access control method that can be applied to various scenarios, such as web service, cloud computing, and the Internet of Things. Next, in this slide, I would like to briefly introduce the data structure we have established. JSON-based fine-grained access control data format is a standardized format used to initiate access requests to access control systems. Mainly consists of a JSON object that contains the request access resource and their fine-grained access conditions. Request ID is the identifier of request. Subject is the identifier representing the access subject. Operation indicates the action identifier of request body, such as read, write, update, and so on. Resource indicates the identifier of access resource. Condition refers to fine-grained attributes of access subject. The next slide will break down the proposed implementation process into the 8 main steps. The client sends authentication information to the server and receives a JWT token. The request sent by the client includes the token, and the payload of token contains information about the accessing subject, access resource, and attributes. The resource server sets fine-grained access control policies for different resources, which are represented by an access control tree. The resource server generates public parameters and a master key with ciphertext policy attributes-based encryption algorithm. It then creates a private key based on the master key and the client's attributes, sending it to the client. The server securely stores these parameters, and the key prevents unauthorized access. The server verifies the validity of token, passes the payload information, and extracts the access information and attribute information. Next slide, please. Based on the extracted information and the predefined access control policy, it is determined whether there is a corresponding policy. If there is, the access conditions are checked to see if they are met. If the conditions are met, access is granted. Otherwise, access is denied. The resource server encrypts the requested resources using the algorithm. The encryption process utilizes public parameters and the access control policy corresponding to the accessed resource. The encrypted ciphertext is then sent back to the client. After receiving the ciphertext, the client decrypts it using the private key and the public parameters. The client verifies once again that only when the attributes in the attribute set meet the access control policy can the access resource be decrypted. The above is all the content of the draft. Thank you for listening. Do you have any suggestions or comments about the draft?
Yep. Thanks, Yingling, for the presentation. I posted the link into the chat window for a document that is from a different working group that may be relevant or at least related to what you are trying to do. You might want to take a look at that one. Are there other comments to the proposal? Just jump to the mic.
Hi, Ralph Bragg. I just had some questions. What's the difference between this and, say, the RA rich authorization request spec and model in terms of the various different attributes?
The question was, how is this different to the RA, or how does it relate to the RA specification? I don't know if you've, there was just, Dima posted it into the chat window. Atul.
Yeah, I think this is a very broad proposal because it covers sort of the format, it covers sort of processing rules about how to generate these things, how to encrypt them, and also how to use them in specific situations. I think, does it make sense to sort of break it up? And also, there's a lot of other work going on, like, for example, in the OpenID Foundation's Auth working group, which deals with, like, that whole working group is probably all about what this one single proposal is about. So I think I'm just worried a little bit about the complexity of this whole thing and whether it can be captured effectively in one proposal.
Okay, so yeah, excellent feedback. Yingling, I guess you will have to look at some of the documents that people or proposals that some people mentioned. I see Kalia just posted another one, another relevant effort or protocol. So there's a lot of other work that relates to what you're doing. So yeah, but anyway, thanks for the proposal, and we always like to get input from newcomers in this. IETF newcomers to this field. So thanks a lot. This concludes our meeting for today, and we see each other tomorrow for our final meeting and we still have a bunch of presentations. So looking forward to see you tomorrow. Thank you. The intra meeting, Christina, we will run a doodle poll to just find out what the most convenient date is that people can attend. Bye, Rifat. Hey. Just wanted to say pretty incredible. Pretty incredible. All this work. As it's sort of